Good morning, Angela.
Good morning.
How are you today?
I'm good. How are you doing?
Good. Real good, because after we're done, I'm going to go out and play golf.
What was that?
I said after we're done, I'm going to go out and play golf.
Oh, that's good.
So yeah, I'm going to have a fun day. Getting it started off right with some math tutoring. And that's the truth. A perfect day for me would definitely have some tutoring sessions in it.
Oh,
Okay,
that's good.
we left off at number 18 last time. So why don't we pick up with 19?
Okay.
If you could kind of try to think out loud, that helps me with how to help you with some of these problems.
I think in this case, what I would do is I would add them together.
Okay.
So 2x, well, no, maybe that's not right.
No, you're on the right track. That's a good.
Okay.
Mm-hmm. So we got 2x equals a plus b.
And then divide it by 2.
So we got x equals a plus b divided by 2.
And so we would plug that into the x
Okay.
and solve for y.
Well, okay.
No?
Which one? Yeah, no, that works. Plug it into which one? Should we?
It doesn't really matter. I guess the top one.
Okay, the first one. So we've got a plus b over 2 plus 2y equals a. So we've got 2y equals a minus a plus b over 2. So we've got y equals a over 2 minus a plus b over 4. So now we have x in terms of a and b, and we have y in terms of a and b. So we could then proceed to multiply the two together, and whatever we get is going to be our answer.
But there's got to be an easier way to do it.
There's a couple. First of all, let me make a few suggestions about this. It's definitely important that you know how to solve simultaneous equations by elimination.
Okay.
There's definitely questions like that where you have to be able to do it. So let's cover that. The way we solved for y was a little cumbersome.
Yes.
Well, what if we, instead of add these two equations, let's subtract them? Also, in other words, the way we solved for x was just fine, but there's really an easier way to solve for y. You're allowed to subtract equations just as fundamental as being able to add equations. So if I subtract these two equations, I'm going to eliminate the x and be able to solve for y directly. So if I subtract equation 2 from equation 1, I get 4y, because 2y minus a minus 2y is 4y, equals a minus b, so y equals a minus b over 4. So that was much quicker, solving for y, and much cleaner. We got something we don't have to manipulate much. So now it would be a question of multiplying that by this. Whoops, my GoToMeeting. Let me turn my camera off, see if that helps a little bit. Okay, so now we've got that over 4. And that looks messy, but in actuality, the top is difference of squares factored. In other words, one of the things you definitely want to know is that a squared minus b squared is equal to a minus b times a plus b.
Okay.
And you want to know this going both ways. In other words, if I'm going to multiply a plus b times a minus b, I'm going to get a squared minus b squared. And then the bottoms, 2 times 4 is 8. So there's my answer without too much problems, E. However, there is an easier way yet to do this problem. That probably is the way I would attempt to do it.
Okay.
Instead of doing all of that messy algebra, even though we did the algebra the cleanest way we could, pick numbers. And here's the clue as to when picking numbers might work. When you have a bunch of variables in the question, and you have a bunch of variables in the answers, then I should be able to pick numbers and back solve. When I say pick numbers, I mean you pick numbers for x and y and figure out what x times y is, and then you go through your 5 answers and figure out which of these equals that number you came up with.
Okay.
Okay? And when you're picking numbers, you want the general rule, pick numbers that work nicely. But in this case, that's not hard to do at all. Pretty much any numbers we pick for x and y are going to work pretty nicely. So let's pick the simplest ones. Let's do x of 2 and y as 1. So what is a equal to?
4.
What is b equal to?
2 minus 2, 0.
What is x times y equal to?
Let's see, 2.
So let's go through each of these answers using this a and this b and see which one is equal to the number 2.
Okay.
Okay? Well, obviously not that one. We don't even have to consider that one. B has promise. That's equal to 2. Interesting. Their suggestion at the back of the book has 2 different answers here, and they didn't mention that B, but I'm glad it did, because this highlights one hiccup to picking numbers.
Yeah, choose different numbers.
Right, but at this point, this looks like the correct answer.
Right.
Okay, so that we have to check mark that. But the problem with picking numbers is sometimes you'll pick numbers where it is possible to get 2 different answers. And if you find 2 different answers that give you that number, then you're right. The answer is to go back and change your numbers. Don't just make it a multiple. In other words, don't go back and make it x equal 4, y equal to 2. Do something like x equal 2. You want to choose numbers that are not going to give you fractions for a and b.
Okay.
You want whole numbers for a and b because you have to do all of this math.
Right.
Math's much easier if you have whole numbers. So first of all, let's see. So b works. C works. D does not.
No.
E works. Interesting. Okay. I say interesting because the answer in the book didn't even mention that B and C work also. So let's try what we said. Let's go back and pick a different number for x and y. This time I'm going to try 3 and 1. That that should be sufficient, I would think.
Okay.
So when x is 3, a is 5, and when y is 1, b is 1. So now, given an a of 5 and a b of 1, x times y is equal to 3. So let's see. That's not 3, that's 5. B still works. Wow.
Huh.
B still gives you 3. And C does not. And E is still going to give you 3 because we have 25 minus 1, 24 divided by 8, so that's 3. Wow, so you'd have to go through a third iteration here to distinguish between B and E. I had no idea. One moment, let me just see what they have to say about this. They do not even tell you that. Wow. In fact, they say if you let x equal 2 and y equal 1, the only answer that equals 2 is E. Did we make a mistake there? A was 4,
No.
B was 0. No, both B and C both equal 2.
They both work.
Okay, so
they messed up.
They did. Let's just real quickly see if I plug in 2 for y. That should definitely take care of the problem. And now we have 3, we have a is 7. The reason I say that is because I'm turning some of these into primes and negatives. So this would be 3 minus 4, so that's negative 1. So x times y is 6. And now let's see if b still works. Yes. No, it doesn't. B no longer equals 6. Because we have B now equals 3.
Right.
So that did eliminate B, and now we can choose E. So that was a crazy long answer to that problem, doing it the easy way. Makes me think that the best way to do that was algebraically, by a lot. Although algebraic had its pitfalls too, so that's a tricky question. But I'm glad all that happened because it allowed us to show what happens if you happen to pick the wrong numbers. And that's not the first time I've ever seen it, although that is the first time I've ever seen a problem where changing the first time you change your numbers, you didn't solve it. And
right.
That's the first time I've ever had to go back twice and change the numbers that I picked. Okay, we have a square and an equilateral triangle. Both have lengths of 5, side lengths of 5. Now, I didn't quite draw this correct. This vertex is clearly not as high as this square. Now let's draw it a little better. Because if this side length is 5, there's no way the altitude is 5 because the hypotenuse is always the highest or the longest side of that right triangle. So they want the ratio of the areas of the square to the area of the triangle.
Okay. So the area of the square would be 25. And the area of the triangle, let's see, 1/2 base times height equals 5. So 2.
There's actually 2 ways to do the area of a triangle. There is a special formula for the area of an equilateral triangle. If you want to memorize it, I'm happy to give it to you. And it does save you time. The question is, how much do you want to load up your memory on things that you can solve by manipulation. In other words, we know how to solve this equilateral triangle. I would suggest that we do both. The area of an equilateral triangle is equal to the side length squared times root 3 over 4, which isn't that hard to memorize. And I don't know, the odds of you being asked the area of an equilateral triangle are not that strong, and I'm reluctant to have people memorize stuff that they can figure out. So the easy way to do this, if you knew the formula for an equilateral triangle, would just be to plug it in, whatever that number is. So we have 25 root 3 over 4. And we're comparing that to 25. So we want to take, how would we do that? Let's assume you knew that area formula. So now what?
Okay, I don't know.
Well, if we want to compare the ratio of the area of the square to the area of the triangle, well, we would put 25, the area of the square, divided by the area of the triangle, which is that. Okay. How do you divide by a fraction?
Invert.
And multiply. So
Yes.
this is the same as multiplying by 4 over 25 root 3. And that, 25's cancel. Always look for that to be able to reduce it. And I've got 4 over root 3 is that ratio. Well, this brings up an interesting problem. You will never find an answer on a math test that has an irrational denominator. I'm not sure who first decided that you should never divide by irrational numbers if possible, but somebody did. So there's been kind of an accepted way to solve this, and it's called rationalizing the denominator. So you're not going to find this answer on the test ever. So we have to change it. And when you rationalize an irrational denominator, you basically multiply the fraction by the number 1, which you can always do. You can always multiply any fraction by 1 without changing it. It's how you make your 1. In this case, the 1 is going to be root 3 over root 3, which changes it to 4 root 3 over 3. That's what I would look for on the test, and that's what D is. Okay, any questions on that technique?
Nope.
Okay, now let's assume we didn't memorize this formula. And let's see if we know that the area of a triangle, the general formula is what? For
the area, it's 1/2 base times height.
Okay, that's what most people know. To be honest with you, I don't have that one memorized. Because I don't like memorizing stuff that I can figure out. So in this case here, what is this dimension?
Okay, it's going to be half of 5.
2.5. So in order to figure out height, we have, if we take this little triangle and draw it down here, this is height, this is 2.5. And we need to know some angles. Well, this is an equilateral triangle, so this is 60. This is 30. So now we can use our similar triangles to figure out what H is. And the similar triangles that you should memorize, because so frequently you have to use similar triangles to solve a triangle. In other words, I could use trig on this, but you don't need to know trig for this test, so let's not go that way. All the triangles you'll be asked to solve will be 45-45 right triangles or 30-60 right triangles. So it's really worth knowing this, what I call my unit 30-60 right triangle. I call it the unit one, kind of like the unit circle if you ever have taken trig, but the unit special right triangles have one opposite the smallest angle. And the rest of it is square root of 3 opposite the 60 degree and a hypotenuse of 2. So if we use this as our basis, and every right triangle that is a 30-60 we know is similar to this triangle, so the ratios of the sides have to be all the same. So the first thing you want to do is find the scale factor, the linear scale factor, which is to say how much is the corresponding side bigger on this bigger triangle here. I haven't drawn it bigger, but we know it's bigger because this side is 2.5 and this side's only 1. And in other words, I'm looking at the side opposite the 30.
Okay.
The side opposite the 30 is 2.5. So what's my scale factor?
It's
2.5 to 1. In other words,
yeah, I'm lost.
Well, we're going to take this side of 2.5 and compare it with the equivalent side of this similar triangle over here.
Okay.
So I divide 2.5 by 1. So now I know that every side in this triangle on the right has to be 2.5 times bigger than this triangle on the left.
Okay.
So what does that make H?
It's going to be 2.5. I don't know why, but I'm just totally lost on this one. I don't get it.
Okay, let's go back then. Let's talk about just similar triangles. Ignore this part of the problem for the moment. In fact, let's do this. A key part of math that you're going to need to know is how to solve right triangles.
Okay.
You're going to be repeatedly presented with right triangles that they give you one dimension. Okay? Let's just take any right triangle. Forget this problem for the moment. Okay. If I told you that this triangle was 4, and I know these are similar because any triangles that have the same 3 angles are similar. This has got 30, 60, 90. This is 30, 60, 90. Which means that the corresponding sides of each of these triangles has to have the same ratio. So I can determine that the hypotenuse on the left is 2. I'm going to memorize this in my brain so I always know it. Each of these dimensions that I know opposite the 30 is 1, opposite the 60 is root 3, and opposite the 90 degree is 2. So as long as I remember that, then all I have to do is compare the known side of this triangle, the hypotenuse, 4, with the same side of this triangle, the hypotenuse 2. So I divide 4 by 2 to come up with a scale factor of 2.
Okay. The
triangle on the right, it's not fair to say it's twice as big because the area is not twice as big. 4 times. But we're not looking at the area at the moment. We are trying to dimension this bigger triangle. In other words, I need to know the side opposite the 30 and I need to know the side opposite the 60. Well, since each side has to be twice what this triangle over here on the left is, then the side opposite the 30 has to be 2.
Okay.
And the side opposite the 60 has to be 2 root 3.
Got it. Okay.
So that's the way we're going to handle similar triangles. Now, let me put a different dimension on this. Let's say that that's all I know. Now what is the scale factor?
Um,
How did I get it before? When I knew that there was a 4 as a hypotenuse, I divided that by the same side of the other triangle. So do the same thing here. Take the side that's opposite the 60, 2, and divide it by the side opposite the 60 on your unit triangle, square root of 3. So the scale factor is this.
okay.
Okay. So now, to figure out this short side over there, what is that going to be?
It's going to be 2 to the square root of 3.
2 divided by square root of 3. And I'm going to ignore the irrational denominator for the moment since we're just demonstrating the principle to you. And what's the new hypotenuse going to be?
4 to the square root of 3.
4 divided by square root of 3.
Yeah.
Yeah, you have to make sure you say that. Otherwise, I would have been tempted to write 4 square root of 3, which is multiplied by it.
Okay.
Okay? So this is the way we solve right triangles. Even if we have a mixture of whole numbers and irrational numbers. That's the only time it gets tough. So the problem we just did down here at the bottom is as complicated as it's ever going to get for solving similar right triangles. Okay? As long as we're doing it, let's not ignore the other most important one. There's only 2 that you have to know. There's the 30-60 and there's the 45-45. This one has dimensions of 1, 1, square root of 2. Memorize both of those. Every part of both of those triangles you want to know by heart. Okay, now I'm going to give you some random similar triangles, and I want you to dimension them for me. Notice that I only need to label one of the angles 45. That automatically makes this 45?
Yes.
Okay. So what are the other 2 dimensions on this?
The angle across from the other 45 would be 3. And the hypotenuse would be 3 square root of 2.
Okay. That's easy because we were dealing with whole numbers and whole numbers. Make it a little harder.
Okay, the other 45-degree angle would be square root of 2. And the hypotenuse would be would it be the square root of 2 divided by the square root of 2?
No, it would be, what's our scale factor? In other words, our scale factor was square root of 2 divided by 1.
Okay.
And then we're going to multiply that scale factor by square root of 2 to get the new hypotenuse. So square root of 2 times square root of 2 is 2.
Right. Okay.
Okay? So you want to be able to handle when your scale factor is derived by dividing an irrational number by a whole number. And you want to be able to handle it when, let's do one other. Let's call this square root of 6. Now what's my scale factor? Well, dimension the other 2 sides. Always remember that first step, though. That first step is to always figure out your linear scale factor.
It's the square root of 2 divided by 1?
No.
I don't know why these are just confusing me.
Okay, well here's the trick. You have to find the corresponding equal sides. In other words, down here we were given a hypotenuse.
Uh-huh.
So we need to look at the hypotenuse down there. And we're trying to determine how much bigger this triangle is than this. Well, it's the same side divided by the same side over here. So it's square root of 6 divided by square root of 2. There's your scale factor. Well, that's equal square root of 3. I don't even have to do that simplification. In fact, let's not do that simplification, although that is a true statement. Square root of 6 divided by square root of 2 can be stated as the square root of 6 over 2 or the square root of 3. But for sake of argument, let's just say, in fact, let's make this the square root of 7 so we can't reduce it. So we'll have the square root of 7 divided by the square root of 2. Now, you see what I'm doing here?
Yeah.
I'm finding the equivalent side that we're given and dividing by it to come up with the scale factor.
Okay.
So now, what is this short side and this short side?
It's going to be the square root of 7 divided by the square root of 2.
Right. In other words, we're just going to take that scale factor and multiply it by 1 to come up with this. Take that scale factor, multiply it by 1 to come up with that. Okay.
Okay.
And one last exercise on this, because this is a really important part of the geometry of this test. I'm going to give you random triangles. And we're going to call this 30 and this 60. And there's going to be a note not drawn to scale. At least there should be. Maybe not. Maybe they don't always say that on the drawings. So I'm going to take this triangle and I'm going to say this side is square root of 2. Dimension the rest of it for me. Scale factor is what?
For 30, 60, 90, it'd be 1.
Always take the bigger one first. In other words, you're always going to be dividing by the smaller one. Occasionally they may give you a triangle where they give you a smaller triangle. Don't worry about it. Always divide by the unit one. Because 95% of the time, the triangle you're trying to solve is going to be a bigger triangle than the unit one. So don't deal in fractions if you don't have to. In other words, if this is twice as large and I divide this by this, my scale factor is going to be 1/2. Then I have to multiply everything by a fraction. You don't want to do that. You want to be multiplying by whole numbers if you can. And most of the time, the triangle they're getting you to try to dimension is going to be the larger of the two. Notice that square root of 2 is 1.4. That is bigger than this triangle over here. What are the equivalent sides? In other words, the only information they gave us, other than it was a 30/60, was that this side is square root of 2. What is the equivalent side in this triangle?
I don't know.
The side that's opposite the 30-degree angle. In other words, I didn't orient this the same way. And when you take your test, frequently they're not going to be oriented perfectly. In other words, it's not going to look exactly like this. So to handle that problem, think of these triangles as, okay, what's the smallest side of this triangle? It's the side opposite the 30-degree angle.
Correct.
I don't know if we went over that last week or not, but in all triangles, the smallest side has to be opposite the smallest angle. Not just right triangles, but all triangles. And the biggest side has to be opposite the biggest angle. So when I'm looking at this triangle here, my first thing is, okay, the side opposite the 30 is root 2. Well, over here, the side opposite the 30 is 1. So my scale factor is root 2 divided by 1. So what is the side opposite the 60 equal to?
It's going to be the square root of 2 divided by, excuse me, the square root of 3.
Not divided. Once I've figured out my scale factor, I have to multiply this scale factor times this side to get this side over here. Square root of 6. Square root of 2 times the square root of 3. What's the new hypotenuse?
It's going to be 2 square root of 2 times the square root of 2.
Right. Okay, so that's our process. We find a scale factor, bigger to smaller, not even bigger to smaller as much as new triangle divided by unit triangles. We figure out which side it is that they've given us, and they've given us the side opposite the smallest angle. So we go to the unit triangle, look for its side opposite the smallest angle, divide the two, come up with the scale factor, and then take that scale factor and multiply it by the other sides to get the two new sides of our bigger triangle. And that is the methodology that you want to follow every single time you're asked to solve similar triangles. And that one right there is about as hard as it gets.
Okay.
Because I didn't have them drawn, oriented the same way, and we were dealing with irrational number compared to a rational number. All kinds of things were in that problem that made it tough. Okay, so let's solve this triangle right there. Notice that this is the 60. It's equilateral, which makes this the 30. Was 60, but it was bisected by that altitude. Whoops. Okay, so we need to solve for h.
Okay, so the side opposite of the 60-degree angle.
Right, but that's not the information we have. The side we have is the side opposite the 30-degree angle. We're trying to solve for h, but what we're given is 2.5. In other words, our triangle is this.
Okay, so the height would be 2.5 multiplied by the square root of 3.
Very good. 2.5 root 3. There's our height. So now let's figure out the area of this entire triangle. Remember, we don't remember this formula. So it's 1/2 base times height. What's the base?
2.5.
5.
Oh.
Be careful. Be
Okay,
careful.
so we're solving for the whole.
Exactly. Be careful with that mistake you just made. Everybody makes it. You just have to make it a few times before you remember not to make it. We have solved for the height by considering half of that triangle. But when we go back and solve, the only reason we solved for the height was because we wanted to solve for the area of the triangle, so we have to go back and consider the entire base, which is 5.
Okay.
Times the height, which is 2.5 root 3. Notice that that's the same as 2.5 times 2.5 root 3.
Okay.
And now, to get the ratios of the area, I'm going to divide the ratio of the square, the area of the square divided by the area of the triangle. Now, yeah, that's a little more difficult than had I used this formula in the first place, because I'm going to divide 25 by 2.5 squared root 3, which is a little harder to reduce and simplify than this was, although not that much harder. Notice that when I come up with this as my answer, I could rationalize the denominator. I could go ahead and square 2.5. So I end up with 25 over 2.5 squared is 6.25. Square root of 3 times square root of 3 over square root of 3. So I get 25 root 3 over 6.25 times 3. That's the same as 4 root 3 over 6 over 3, 4/3 root 3. Notice that 25 over 6.25 is 4. So by the time I rationalize it, I have 4 root 3 over 3. Not sure what the moral of this problem was. Probably that it's worth having this memorized. Although, you certainly need to be able to do everything we did there. For one thing, I'm guessing that 75% of the right triangles you're going to be asked to solve are not going to be equilateral triangles. And so most of the problems where you have to solve for a triangle, you've got to be able to do this similar triangle method, for sure.
Okay.
Definitely need to be able to do that. And since we need to be able to do that, that's an easy way to solve that triangle for the height, if you don't know this formula here. If you have a really good memory and you want to go ahead and add that to it, then it might come in handy if you run into that problem on the test. Definitely would come in handy. We could see that it took quite a bit of time off of solving the problem by knowing that area formula. Although even then it wasn't that straightforward. We still had to do this, if you'll remember.
Right.
And we had to know how to do that. Okay, let's go on. Don't worry that we're taking 20 minutes for each problem here. What's happening is that each problem is highlighting a math technique that you need to be able to do.
Right.
So this is good. We're discovering the areas where we want to look at math. Okay, that's the finish of that diagnostic test. So let's go back. So we finished that. Let me make a note. And let's do test 2. Let's go back and test 2. Apologize for the quality. Sometimes the quality isn't bad. Sometimes it sucks. Hold on. That's not, I don't want test 2. We didn't finish. We only got through the first part of test 1. Test 1 has 2 parts to it. And this is the second part. Yeah. Want to be fairly methodical. And okay, I'm going to erase this now, but You've had time to copy that and
I did, yes.
put it on the list of things that you want to memorize,
Yes.
along with the technique of doing it. Okay, number 1. Which is bigger, 1 over pi or 1 over root 10?
1 over root 10.
Okay. Well, pi is 3.14. Root 10 is 3.16 and change. So here's a key thing with data comparisons, or quantitative comparisons, whatever they call this. If the denominator is bigger and the numerator is the same, then this is the smaller number.
I realized that after I said it.
Okay. And likewise, if the numerators are the same and the denominators are bigger, then it's the denominator. Excuse me. If the denominators are the same, in other words, if I have this problem, 3 over 721 compared to 4 over 721, then I know this is bigger because the denominators are the same and the numerators are different.
Okay.
So it's only backwards when it's the numerators that are the same. In other words, 1 over 3.17 has to be a smaller number than 1 over 3.16 because this is bigger than this.
Okay.
And that's one where you definitely would use your calculator to get square root of 10, but you only need the first 2 digits of it in order to compare it with this.
Okay.
Okay. This is an interesting one. Yeah, I'm may have to read it to you, or maybe if I blow it up just a little bit, it'll help. N is an odd positive integer between 700 and 800. Which is bigger, the number of prime factors of n or the number of prime factors of 2n?
Well, my first thought would be 2n because twice the number of prime factors. Okay, the number of the prime. Yeah, I don't know. My first response would be 2n, so quantity B.
Okay, if I said how many prime factors are there in the number 10?
Let's see, there's 2.
2 and 5.
Right.
If I multiply 10 by 2, how many prime factors are in the number 20?
4.
Well, there's 2, 5, and another 2, so there's only 2.
2, okay.
Okay? So just because I multiplied n by 2 doesn't necessarily make it have more prime factors.
Got it.
Okay? Because all of the factors of 2n are going to be included as factors of 10 in terms of prime factors.
Okay.
In other words, sure, a factor of 20 is 4, but it's not a prime factor. If I break 20 up into its prime factors, I get 2, 2, and 5. So the number of prime factors are only 2. So at second glance, it seems like they might be the same.
Right.
Okay, and now there's one piece of information that was key here. N is an odd positive integer. Sorry, I covered that up. I didn't do that on purpose. That makes a difference, and you should look at that. Why are they saying n is an odd positive? notice that if I take an odd number, like 25, how many prime factors of 25 are there?
1.
How many prime factors of 50 are there?
2.
In other words, if I have an odd number, the number of prime factors of 2n is always going to be 1 more than the number of prime factors of n, because 2 is always going to be one of them, and 2 is never going to be a prime factor of an odd number.
Oh, okay.
Doesn't matter if my odd number is 721. I know that 2 is not a prime factor of that. But the moment I double it and make it 1442, all of a sudden 2 does become a prime factor of that. So for odd numbers, I do pick up a factor. So the answer here is B. And I kind of hate this question because the people who get this right are going to be the people who give it a very cursory glance and say that 2n is bigger than n, therefore b is greater, and go on to the next.
Yeah, which is kind of what I did.
Well, and that would be right, but not for that reason. Yeah. So that's why I don't like the problem. It kind of rewards the wrong technique. Whoops, hold on. Trying to get this centered. Okay, x is less than y. What's bigger, the average of x plus y or the average of x plus y plus y? What's a good way to solve this?
This one I pick numbers.
Absolutely. Give me an x and a y.
X is 1 and y is 2.
What's the average of x and y?
1.5. 3 over 2.
What's the average of x plus y plus y?
5 over 3.
That's a bigger number. Now, you're good with comparing these two numbers?
Yes.
Knowing that 5/3 is bigger than 3/2? Okay. Much, that's by far the easiest way to solve this problem. And it has to be correct. In other words, as long as we pick an x less than a y, that's always true. And I suppose from the first set of numbers that you wouldn't be 100% sure that you had the right answer, because maybe we just got lucky with numbers. But in this particular problem, I would be comfortable with picking just 2 numbers, discovering quantity b was bigger, and going on to the next.
Okay.
There is some intuitive thinking going on here. If you try to solve this algebraically or logic-wise, because x is less than y, the average of x and y has to be smaller than y, right?
Yeah.
Average a big number and a little number, the average is definitely less than the big number.
Correct.
Okay, so if I take that big number and add it into the mix, I've got to increase the average. In other words, instead of x plus y, I know I'm adding a number y that is greater than this average was. So if you add a number greater than your average, you're upping the average.
Okay, yeah, that makes sense.
Now, if I'm making soup and I put a certain amount of salt in it, I've got a saltiness. I got an average saltiness. Well, if I add more soup that's saltier, then I'm going to increase my average saltiness of that soup.
Got it. That makes sense.
Okay. Okay. This is angle C, this is angle D, this is side 10, side 11, and this is 135 degrees. And they want you to compare angle C with angle D.
Okay. I think I'm going to have to really work on my geometry.
Okay, this goes back to the rule that I was saying where the longest side of a triangle has to be opposite the biggest angle. The smallest side has to be opposite the smallest angle. So clearly this hypotenuse has to be the biggest side.
Correct.
But we don't care about that.
Right.
If the hypotenuse is the biggest side, what's the smallest side?
It's going to be D.
10. And then
Yeah,
the angle opposite that would be the smallest angle. So
yes.
D has to be the smallest angle, so C has to be bigger than D.
Correct.
Okay. Oops. Let's do this one last one.
Okay.
A and B are both positive, and A is less than B.
Aren't these going to be equal?
Let's try some numbers. In other words, yeah, we don't want to have to convert this A% to some number. So let's work with some numbers. Give me an A and a B.
A can be 10.
Good.
And B 100.
Okay.
Or is that too big?
No, that'll work just fine. So what is A% of 1 over B?
10% of 1 over 100 equals 1/10?
1,000th.
Oh,
Yeah.
the wrong way.
We're multiplying 0.1 times 0.01.
Okay.
And that's equal to 0.001. Okay? So now what is B% of 1 over A? Well, B was 100. 100% of 1/10 is 1/10.
Right.
B is definitely bigger.
Bigger.
And if it's bigger for one set of numbers that I picked, it has to be bigger for all.
Okay.
See why? In other words, if this was dependent on the numbers that I picked only, and let's assume that there's another set of numbers out there that would give me the reverse, this couldn't be a question. In other words, they're saying that for all A and B, one of these is always going to be bigger than the other. If it was only half the time, I wouldn't be able to answer this thing. Yeah, I would not be able to answer this thing. Unfortunately, that's one of the answers, is you can't determine it. Again, there's kind of an intuitive knowledge here that if for these numbers it's true that B is greater than A, I'm going to take a leap of faith and assume that for any numbers that I pick, that's going to be true.
Okay.
Okay? In other words, I'm not going to spend the additional 30 seconds going back and picking a different A, although maybe, you know, just as a general guideline, it couldn't hurt to go back and pick an A and a B that are different relative to one another.
Okay.
So let's pick A of 100, B of 10. and see if we get the same thing. So now we got 100% of 1/10. So A is 1/10, quantity A. And for B, yeah, this would make me comfortable enough. Just reversing the numbers and making sure that quantity B is still bigger. Well, quantity B is now going to be 10% of 1 over 100.
Which is now going to be 1/1000.
Hold on. I violated my premise when I did that.
Oh, yeah, because
B has to be greater than A.
Okay.
Okay. Now I understand this problem fully. If they say this, then quantity B is always bigger than quantity A. If this was not there, we would not be able to tell.
Okay.
And I've just proved it by switching them. In other words, when I let A equal 100 and B of 10, quantity A ended up being bigger. So I picked two sets of numbers where in one set quantity B was bigger and the other quantity A was bigger. But only because I couldn't pick this set of numbers. If I really wanted to pick another set of numbers, I would pick another set where A was smaller than B.
Okay.
And then try the problem, compare the answers, and if quantity B is still bigger, go with it.
Okay.
And in this case here, might be worth that second set of numbers just to figure it out. In other words, the first set was 10 and 100. It might be worth going back and trying 2 and 3 and making sure that quantity B is still bigger. All right, why don't we stop there?
Okay.
And let's see, it looks like we're going to do 12 sessions. Is that correct?
Yes.
Okay. And I think this is our third one. So we got 9 more. And I think I've got plenty of material here to go over. So I will talk to you next time.
Okay.
And you want to go online. I'm wide open from starting tomorrow. My tutoring pretty much has I still have 3 sessions today. I had 5 yesterday, but everybody's finals are today and tomorrow. So I'm very open for the rest of the summer. So you shouldn't have any problem. You shouldn't have any problem scheduling. I love 9 a.m. if it's good for you, because that gives me
I do too.
Go out and play golf. I usually play golf if I have an off day, from 11 to 4 or 5. So if you have a choice, I would appreciate it if you don't schedule in the middle of the day. If you don't have to.
Yeah, and I usually don't like the middle of the day either. I'm more of a morning person.
Great, me too. In fact, this time is perfect. So, okay?
Okay, thank you.
I will talk to you next time, Angela.
Okay,
Bye-bye.
bye-bye.